Next topic is sight an object right ahead at a certain distance with current prevalent in the area but without any leeway. So let's see how do we solve this type of question. As you see, we need to sight a particular object, most of the time a particular lighthouse. It should be right ahead at a given distance of. The lighthouse should be sighted right ahead at a given distance of, and there is some current in that area. So we need to find out our CTS. The CTS is not known to us, so that the lighthouse is right ahead at the given distance. Let's first see what all information or data items which are provided in this type of question. They will tell us the initial position, observed position or fix of the ship. The engine speed is given to us. A reference object which needs to be sighted right ahead is given to us. At what distance the object should be right ahead is also given, and the direction and rate of the current, set and rate of the current is also given to us. So this is what all is provided, and what we are required to find out is the course to steer. So let's try to plot this information onto the chart. We have the chart on our screen. So let's first plot our initial position. You can see the initial position marked by this green color circle. Let's name it as A. This is our initial position. Let's identify the object which we are required to keep right ahead. In this particular example, we are assuming that this hook head lighthouse is to be sighted right ahead at a given distance. So let's name the object as O. Now the set and rate of the current which is prevalent in the area is also given to us. All these items are provided. We are required to find out the course to steer to sight the object right ahead at a given distance D. So let's now see how do we go about this question. Now, first of all, in the first step, we should be clear in our mind that this is also a little different type of question. Different in a way because the questions which we have done till now, we had the information given to us in the question. We plotted that information onto the chart and got our answer. Now, in this particular question, you cannot find out how to do this or the method to do this question by thinking out. So let us say if you get this question first time in your exam, it will be difficult to think about the procedure and then start the plotting. You need to know beforehand, before you start solving this question, that what is the method with which we should be solving it. So the method needs to be known beforehand. Once you know the method, you know the stepwise technique, you can follow it, and in the end you will be able to see that the technique which you followed is correct. So it is a typical question in a way that you need to know the procedure beforehand. Okay, right now we don't know it, but by the time we complete this, you will have the procedure known to you, and then you can follow it stepwise and solve it. So this is how it is different from the previous questions. So step number 1 in this question, we need to find out the time required to cover the given distance. Let us say they want us to have this lighthouse right ahead at 12 miles off. So we need to find out what is the time that our ship requires to cover this 12 miles distance using our engine speed. So let's assume our engine speed is also 12 knots. So we know that we require 1 hour to cover this distance. So this is the first step. Calculate the time required to cover the given distance d using the engine speed. Now, once you have that time known to you, we can proceed ahead. Once the time is known, we now have to calculate
Sir,
drift of the current. You see, the set and rate of the current is given to us. We know the rate, but we need to calculate the drift of the current. So drift is to be calculated for how much time? For the same time which we have obtained just now. So we have
sir,
just now found out the time which we need to cover the given distance using our engine speed. In the example which we took just now, it was 1 hour. So we need to find the drift of the current for this period only.
Go ahead, beta.
सर एक छोटा सा डाउट था सर, ये जो डी डिस्टेंस है वो ए से लेके ओ के बीच में है या फिर ओ पे हम 12 माइल्स ऑफ का आर्क बनाते हैं और फिर ए से लेके उसके बीच में डिस्टेंस निकाले हैं?
नहीं बेटा, this D is the distance of at which the lighthouse is to be sighted right ahead.
तो मतलब एक तरीके से हम ओ से सेंटर लेके 12 माइल्स का आर्क बनाते हैं, मतलब जैसे 12 माइल्स ऑफ बोला है और फिर ए से लेके उस आर्क के बीच की डिस्टेंस, करेक्ट सर?
नहीं बेटा, नहीं 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 नहीं, ए से लेके उस आर्क के बीच की डिस्टेंस की कहीं बात ही नहीं हो रही है. ये जो डिस्टेंस डी है ये हमें क्वेश्चन में बताया गया है. लेट अस से उन्होंने बोला है ये जो हुक हेड लाइट हाउस है, व्हेन यू आर 12 माइल्स अवे फ्रॉम दैट लाइट हाउस इट शुड बी राइट अहेड. सो दिस डी डिस्टेंस इज दैट 12 माइल्स डिस्टेंस.
ओके ओके, अच्छा ओके सर.
Okay, it's very
जो
simple.
ओके
So it is the same distance at which the lighthouse has to be sighted right ahead.
एज गिवन इन द क्वेश्चन.
Correct, that's right.
ओके, थैंक यू सर.
Okay.
So in this example, it was 1 hour. So whatever the drift of the current is for that 1 hour, that is what we need to calculate. So once we have the drift known to us, now we can start the plotting. So what we will do is, from the object O, in our case, the hook head lighthouse, we are going to draw the current vector, that is the set and drift of the current, which we have just now calculated. The drift is for the time duration which we need to cover the distance using our engine speed. And we will plot that vector starting from the object, in this case, the hook head lighthouse. So let's plot the current vector. I have plotted the direction of the current vector. The length is equal to the drift in the same time which we require to cover the distance. The current is marked with 3 arrows. So let's make this marking. You can see the current vector. The point where the current vector ends, let's name that point as Bravo. So you see on the plot, Oscar Bravo is the current vector. The duration of the vector is the time required for us to cover the given distance. Now in the you can see it here also. The set and drift is for the time which is required to cover the given distance with our engine speed. Now what we will do is we will join our initial position A in this case to the point where the current vector ends, that is point Bravo. So join alpha with Bravo. Let's plot it on the chart. So you have this line joining alpha to Bravo. This line which we have just now plotted on the chart is our course made good line. So right now, a lot of questions will be coming in your mind. How is this our course made good line? The length of the current vector is for the time which is required to cover the given distance, but AB side could be of any length. So how this is our course made good? Let me explain the full procedure. It will become clear in your mind now. So AB is our course made good. Course made good is marked using double arrows, 2 arrows. So let's plot these 2 arrows here. You can see the 2 arrows plotted on the CMG. Now in the next step, we have to draw an arc. So pick up your compass and open up your compass equal to the distance of which we need to have from this object. The distance of at which this object should be right ahead of us. So open up your compass equal to that distance. Keep your compass centered at the lighthouse, in this case the hook headlight. So compass is centered at hook headlight. The compass is open, radius is equal to the distance at which it should be sighted right ahead. And now we are going to draw an arc so that the arc cuts our course made good line AB. So let's draw that arc. You can see the arc plotted on the chart now. This arc is centered at O, which is our object, and the radius of this arc is equal to the distance at which it should be sighted right ahead. So the point where the arc cuts our course made good line, let's name that point as Charlie. So you can see this Charlie point here. Now this Charlie point, or the position, is that point where the object is going to be sighted right ahead. When we are moving on the AB course made good track, it is at this particular point Charlie that the hook headlight will be sighted right ahead. Now how is this possible? As I told you, line AB is our course made good line, and we have found out this point Charlie. Now Charlie to Bravo, CB, is the distance made good in the calculated time, the time for which we drew the current vector, the time in which we will be covering up the distance at which we are required to sight the light right ahead. So this Charlie Bravo is the distance made good for that particular time. If required, we can also find out our speed made good. Once you have the Charlie Bravo distance made good, you have the time also in which this distance has been made good. So we can calculate the speed made good of the ship while moving on this track if it is required. Now, how is this Charlie Bravo the distance made good in this particular time? For this, let's draw a line joining point C, the Charlie point, with our object O, which is the hook head lighthouse. So let's join these two and mark this line CO. This Charlie to Oscar is our course to steer. So let's mark it with a single arrow. You see the single arrow being marked here. So Charlie to Oscar is our course to steer. Oscar to Bravo is the set and drift of the current. And Charlie to Bravo is the distance made good and the course made good. In fact, this triangle which you see, Oscar, Bravo, Charlie. So OBC, Oscar, Bravo, Charlie triangle. All the three vectors are for the same duration. that is the time required to cover this distance off from the lighthouse. So Charlie to Oscar, you can see it here on the chart, is the distance off at which the light is to be sighted. Remember, this arc was drawn with a radius equal to this distance off. And if you see this triangle OBC, Oscar Bravo Charlie, the duration of all the vectors, or the duration of the course distance current triangle, that is the OBC triangle, is for the time required to cover the given distance using our engine speed. Let us say if distance was 12 miles and our engine speed was also 12 knots, then this triangle is for 1 hour. So Charlie to Oscar is the CTS and engine distance for 1 hour. Oscar to Bravo is the set and drift of the current for 1 hour. Remember, Oscar Bravo drift was calculated basis this particular time only. And obviously, when Charlie to Oscar and Oscar to Bravo are for the 1 hour duration, then the third vector, that is Charlie Bravo, the green color course made good vector, will also be for the same duration. So now you can see why did we follow this particular method. Now everything falls in place. It becomes clear why these steps have been calculated or marked in this particular way. So that is the special thing about this particular question. You will not come to know beforehand why these steps are being taken. But once the plot is completed and you look at the plot, everything falls into place and it becomes clear that this plot which we have made is for the given time duration. And you see at point C, when the ship is at point C, the heading will be in the direction of CTS, course steered, and it is pointing right into the lighthouse. So hook head light is going to be right ahead when the ship is at C point, the Charlie point. However, the track on which the ship is actually moving is the green color track, that is the course made good track. So ship will be proceeding from Alpha to Charlie and then Charlie to Bravo over the ground. But at point Charlie, the hook head lighthouse will be right ahead. Now, before you reach at point Charlie, you are somewhere in between Alpha to Charlie. This hook head lighthouse will be on your starboard bow, at some place on your starboard bow. So at point C, it will be exactly right ahead. And when you cross point C and you are somewhere between Charlie to Bravo, you will see this hook head lighthouse crossing over to the port bow. So in fact, this question can be asked to you in a different language. Instead of asking you, find the course to steer so that this lighthouse can be sighted right ahead at this particular distance off, they can also ask you that if you are moving on this particular track, find out at what time this lighthouse will be crossing your bow. Okay, because you see the Charlie point is also the point where the lighthouse is going to cross from starboard bow to the port bow. So in some of the questions, the question may be twisted, the wording may be twisted slightly, and they will tell you to find out the position at which this particular lighthouse crosses your bow.
So beta, have a good look at the plot. Let me know your doubts.
सर क्रॉसेस योर बाव में भी सेम CTS आ जाएगा ना, सेम ही है ये. जब हेड पे होगा।
Yeah, that's right, beta. That's right.
सर एक चीज पूछनी थी सर, जब अलाउ करते हैं हम लोग फॉर करंट तो लीवे इज अप्लाइड फर्स्ट ना सर?
That's right, beta. When we allow, leeway or wind is allowed first and current is allowed later.
And for counteracting sir, when counteracting first current and then leeway, correct sir?
That's correct, beta. That's right.
Okay sir, thank you.
Okay. So shall we move ahead, beta? Okay.
Let's move on to our next topic now. The next topic which we have is steering safe courses using a single position line. This is also known as blind navigation, and this is done in case of restricted visibility. So let's see what this question actually is and how do we go about solving it. Now, before we move into the question itself, let's first try to understand what is the scenario in which this question is based. Once you understand the scenario, it becomes very easy to solve this question. So this question is set in a restricted visibility situation where position fixing is not possible for us. We are given a single position line at a certain time. A fix is not available to us. Why the fix is not available? Because of the restricted visibility. The observer has just managed to obtain a single PL, and after that he is not able to fix the ship's position. We are now required to either reach a destination position or we are required to pass a certain object keeping a safe distance off. It could be a lighthouse or a prominent land object where we are trying to pass and we need to keep a certain safe distance. Or in the second case, they could give us a certain destination position like a pilot boarding ground where the vessel needs to reach. Now, if initial fix was available to us, it would be very easy to do this kind of question. Then it becomes exactly similar to what we do in a passage plan. So if initial fix is available, this can be easily done by laying the courses exactly as we do in a passage plan. But the tricky part here is how to find the courses basis a position line. We are not aware of where our position is. What we know is that we are somewhere on the said or given position line.
So beta, is the scenario clear?
Yes sir.
Yes, sir.
Okay, all right.
Let's open up the chart now where we will be solving this kind of a problem. So you see a chart, you see a certain area. Let's first try to see what all data is provided to us in these questions. The question gives us one position line taken at a certain time. Along with this, the question gives us a certain safe distance which we should maintain from an object. So a safe distance to pass an object, or in some of the questions, they may give you a certain position to reach. Say, for example, a pilot boarding ground. You need to reach that position. The question provides us the engine speed of our ship. They also provide us with the direction and rate of the current, if there is any current prevalent in that area. And in case any wind is present, then the direction of the wind as well as the leeway angle is given to us in the question. So this is all the data which is provided to us. What are we required to find out? We are required to find out what safe courses do we need to steer object at the specified safe distance or to reach our destination position. The second thing which we are required to find is, if you note carefully, the name of this method, steer safe courses using a single PL. It mentions courses. So this tells us there has to be more than one course. Now, if there are more than one courses, there has to be a course alteration. So the second thing which we are required to find out in these type of questions is, what should be the time to alteration? When you start moving on your first course, after how much time you should be altering to the next course? So these are the items which we are required to find out. What safe courses should we steer to pass at a safe distance from the given object or to reach a certain destination, and what should be the time to alteration? Let's see the method now, step by step. How do we solve this kind of a question? The first thing which we need to do is a position line which is given to us. We will first draw that position line on the chart. Now, let's assume they have given us the bearing of a certain radar conspicuous object here. You can see this diamond on the chart. So they have given us the bearing of this particular object. So let's plot the bearing which is given. So you can see the bearing line plotted here. Now, they have also given us a safe distance to be passed from a certain object. So in this case, they have given us this particular object, worm's head, and we are required to pass this worm's head at a certain safe distance, maintaining a certain safe distance. So in the second step now, we will draw the given safe distance circle around this object. So keeping our compass on this object, which is the worm's head, and opening up the compass equal to the safe distance which is given to us, the safe distance which we need to maintain from this particular object, we will be drawing a circle. So let's draw the safe distance circle now. So you can see this safe distance circle marked on the chart. We have to maintain this particular safe distance from this object, that is the worm's head point. Now you see in this scenario, if the initial position was given to us, it would be very easy for us to find the course. we can easily find what should be a safe course to steer by drawing a tangent from our given position to this safe distance circle. Let me show you how. Let's assume we are given an initial fix. You can see the position marked here on the chart. We are given an initial position. Now, if you want to pass a certain safe distance from the worm's head point, it is very easy. You have to just draw a tangent from this particular position to this safe distance circle. And you know this is the course which you need to maintain, and you will be passing with the required minimum safe distance from the worm's head point. But the challenge here is that we do not have the initial position given to us. What we have is this PL, and our position can be anywhere on this position line. Now, depending upon where our position is, the course is going to differ. If our position was somewhere here, the course would be like this. If our position was somewhere here, the course would go like this. And if our position was somewhere here, the course would be different. So let us see now, how do we obtain the safe courses when we do not have our initial position? How is it possible to find out a certain course or courses which can help us maintain the safe distance irrespective of knowing our initial position? Now for this, we have to take any arbitrary point on the initial position line. So on this position line, let's pick up a certain point. Any point of your liking you can pick up. Let's pick up this particular point here, and we name that point as A. Now from this point A, we are going to draw our first course made good. The first course made good which we require, that we are going to plot from this point A, which we have arbitrarily picked up. This could be any point on the initial PL of your choice. Now, how do we draw our first course made good? The first course made good has to be perpendicular to the given position line. So we draw the course made good in such a way that it is perpendicular to the position line which is given to us. So let's plot it on the chart. So you can see in this green color, I have plotted the initial course made good, the first course made good, and the direction of this course made good is perpendicular to the initial position line. Why we have taken a perpendicular? As we complete the plot, you will understand the reason why a perpendicular course made good has been drawn here. The course made good is represented by double arrows. So let's mark it with double arrows here. Now, in some questions, it is possible that they may give you the first course made good in the question itself. In some of the questions, the course made good, first course made good, may be given to you. Now, if that is the case, the question becomes simpler. Whatever course made good is given to you in the question, you have to mark that same course made good from this arbitrary point A. We have the initial course made good plotted on the chart now. Now in the next step, we have to draw a tangent to the safe distance circle. We can see the safe distance circle plotted on the chart. centered on the worm's head point. Now we have to draw a tangent to this safe distance circle. Now there are infinite number of tangents which can be drawn. What tangent are we interested in? We need a tangent to this safe distance circle, which is parallel to our initial position line. You can see the initial position line plotted on the chart. We require a tangent to the safe distance circle parallel to this initial PL. So you can pick up your parallel rulers, set squares or sliding rulers, whichever tool you are using to draw parallel lines. Align it with the initial PL and then move it to draw a tangent to the safe distance circle. So let's plot it on the chart. So you can see now a tangent line plotted on the chart, a tangent line to the safe distance circle, and this is parallel to our initial PL. Now, in case they give you a certain destination position which you have to reach, then in that case there will be no safe distance circle. So in that case, this parallel line has to be drawn in such a way that it passes from your destination position. Say if you want to reach to a pilot boarding ground, you have to draw the tangent, you have to draw the parallel line in such a way that it passes through that pilot boarding ground. Now you see this line which we have drawn, the tangent line, it meets our first course made good at this particular point. Now let's name this point as Bravo. So this is point Bravo, where this tangent line is meeting our first course made good. Now let's name the tangential point also. Let's name it as C. So you can see the tangential point mentioned here. Now this line AB which you see on the chart now, Alpha Bravo, is our first course made good and our first distance made good. So our first course made good should be in this particular direction, and the distance made good on our first course should be distance AB, Alpha Bravo. Just to clarify, these points A and B are not our actual positions. If you remember, in the beginning, we had picked up this point A as any arbitrary point on the initial PL. This was not our fix. We do not know our fix in these questions. So A and B are not our positions. They are arbitrary points picked up, but line AB, or you can say vector AB, is our course made good and distance made good vector. Okay, now this line Bravo to Charlie BC is our second course made good. This is our second course made good. Let's mark it with 2 arrows. So I have marked the second course made good Bravo Charlie with 2 arrows. Now just to clarify here, Bravo Charlie BC gives us the direction of the second course made good, but BC does not give us the distance made good. Bravo Charlie does not represent the distance made good. Now why is that so? That is so because Bravo is not our vessel's position. Alpha and Bravo are arbitrary points picked up by us to do the plot. They are not the actual positions of the ship. So ship could be anywhere on this line BC, not necessarily that it will be at point B only. So BC does not give us the distance made good, but BC direction gives us the course made good. Now, once we have both the course made good on the chart, we can now use the other data which is available to us. We have the set and rate of the current, which is given in this question. We have our engine speed, which is given to us. Using this data, we can now construct the course, speed, and current vector triangles. So we will first construct this course, speed, and current vector triangle at point A. So first of all, from point A, I'm going to mark my current vector. This is the direction of the current which was given to us. Current is represented by 3 arrows. So let's mark it with 3 arrows. The point where the current vector ends, let's name it as point D. So alpha delta AD is the current vector. Now we also have our engine speed known to us. We can make this triangle for 1 hour. So the length of this vector alpha delta is the rate of the current or the drift of the current in 1 hour. Now we have our engine speed. So we know what distance are we going to cover in 1 hour. So we open up our compass equal to the engine distance of 1 hour. Center the compass at point D and draw an arc. So you can see this arc drawn here. This arc cuts line AB, which is our course made good line, at a certain point. Let's name that point as E. Now if I join delta to echo DE line, let's join it. So I have joined it using the blue color vector. Now this blue color vector is our course to steer, CTS vector. So if you look carefully, triangle alpha delta echo is the course, speed, and current vector triangle at our initial arbitrary point A. So you have the current vector alpha delta for 1 hour. You have the CTS vector delta echo, the blue color vector for 1 hour, and alpha to echo AE, the green color vector, represents the course made good and speed made good vector relevant to 1 hour. Now we can repeat the same process at point B to find our second course to steer. So I will plot the current vector here. Let's mark it with 3 arrows. Let's name the point where the current vector ends as F. So Bravo Foxtrot is the current vector again for 1 hour duration. Now we open up our compass equal to our engine distance of 1 hour. Center the compass, keep the compass centered at point F and draw an arc now so that it cuts line BC. You can see this arc drawn here, cutting line BC at a particular point. Let's name that point as Golf. Now if I join Foxtrot Golf FG, I have joined it with a blue color line. This blue color line or blue color vector, Foxtrot Golf, represents our second course to steer. So I have marked it with a single arrow, course to steer it marked with single arrow. So if you see the second triangle, Bravo, Foxtrot, Golf, this is the course, speed, and current vector triangle at point B. So we know both the courses to steer, and we can also find out the speed made good on both the legs. Alpha echo, as we saw just now, gives us the course made good and speed made good for the first course, and Bravo Golf BG vector gives us the course made good and speed made good for the second course. Now, in case there is a wind present in the area, the question will tell us what is the leeway angle, and they will also tell us about the wind direction. So we will have to counteract the leeway on both the legs. You can see delta echo is the first course to steer. If wind is there, then delta echo will be our leeway track. So if we know the leeway angle and the direction of the wind, we can counteract the leeway to find out what will be our course to steer. Similarly, Foxtrot Golf is our second leeway track in case wind is affecting the ship. So we have the leeway angle, we have the direction of the wind, which is given to us in the question. So we have to counteract the leeway to find our course to steer. Usually the wind direction remains same at both the locations. They will give us a single leeway angle and a single wind direction, which will be applicable to both the courses. Now, in case they have asked us to calculate the compass course to steer, we will have to find out the compass error by using variation and deviation. We apply the variation and deviation or the compass error to our CTS to find out the compass course to steer. Now, the second thing which we were required to find out was what should be the time for alteration. Now, to find out the time for alteration, we know that when we are on our first course, we have to cover a distance equal to AB, Alpha Bravo. Alpha Bravo is the distance to be covered, and we know our speed made good is Alpha Echo. So if you divide Alpha Bravo, that is the total distance to be made good, by Alpha Echo, which is our speed made good, you can immediately find out what is the time interval for alteration of course. Now, time to reach point C cannot be determined, cannot be calculated. Why we can't do it? Because Bravo Charlie does not represent the distance made good on the second leg. Alpha and Bravo were hypothetical points which were picked up by us. So Bravo is not the actual position of the ship, and Bravo Charlie is not the distance made good on the second leg. So even though we know what is the speed made good on the second leg, we still cannot find out our ETA to point C.
So beta, have a good look at the plot. Let me know doubts coming at anywhere in any of the steps.
3 to हमने 10
क्या सर initial position?
Ask again, beta.
ये question में sir what will be required to find out, sir? Not the initial position?
No, they will not ask us to find the position. They will just ask us what courses do we need to steer.
Okay, so that is DE and FG, no? So those two courses.
That's right, beta. DE and FG. Okay. To understand it, just assume that you are in restricted visibility. GPS is not there. You got a PL. You took a bearing of this 14 on point light, 14 on point radar conspicuous point. And after that, the visibility deteriorated, zero visibility. Now you do not have GPS. So now you want to find out what course should I be steering. I don't have any means of position fixing to me now available to me. So what course should I steer and for how long, and when should I alter so that I remain safe? This is the scenario.
सर
हाँ बोलो बेटा।
सर इसमें ये जो हमने BC मारी थी लाइन पैरेलल, वो सर मतलब सर्कल के उस साइड में भी टेंजेंट मारी जा सकती है ना? इस साइड में कैसे मारी थी मतलब?
ओके बेटा,
ये
नंबर
समझ नहीं आया।
you are saying the tangent can be drawn here also?
ये सर ये पॉसिबल हो सकता है ना सर?
ओके बेटा, आप टेंजेंट अगर यहाँ पे लगाओगे, इस साइड में लगाओगे, then it will go over land ना. So certainly we cannot navigate over land, so that cannot be our course made good.
अच्छा, मतलब वो डायरेक्शन ऊपर की तरफ उसके ऑपोजिट में मारनी है।
The tangent should be such that it is parallel to our initial PL. So जो हमारी initial PL थी, हमने उसके parallel ये tangent draw कर दी, and this tangent should be in navigable waters because this tangent is going to become our second course made good.
बट सर ये अगर लैंड के नीचे नेविगेबल वाटर्स ही है ना सारा, मतलब अगर डिस्टेंस इसमें तो डिस्टेंस बहुत कम है, अगर बाय चांस हमें किसी और क्वेश्चन में डिस्टेंस ज्यादा मिले और अगर इस साइड में पॉसिबल हो ये टेंजेंट मारना,
Right.
तो फिर वो इस साइड में जैसे नेविगेबल वाटर्स भी है तो इस साइड में भी मारी जा सकती है, दोनों साइड में पॉसिबिलिटी हो सकती है ना सर?
Okay beta, you are saying that we have navigable waters in this area also, right?
यस सर, ये नीचे मतलब नेविगेबल वाटर है तो यहाँ पे मतलब क्यों नहीं आ रही है टेंजेंट? जैसे ये PL है, PL जा रही है नीचे की तरफ हमारी फर्स्ट वाली,
Right.
ऐसे ही टेंजेंट भी तो नीचे की तरफ जा सकती है ना सर यहाँ से, अगर टेंजेंट मारेंगे।
उससे
I
पास
didn't,
होना है ना एट सर्टेन डिस्टेंस।
I didn't get you.
नहीं सर, वो बोल रहे राइट ऑन द
तो सर
केस में
पूछ रहा है
दोनों
कि सर नीचे
साइड
जाना चाहिए
टेंजेंट
द सर्कल।
मेंटेन हो जाएगी, उसमें उस केस में क्या करेंगे? मिड सी राइट ऑन है तो रडार पे तो आ जाएगी रिस्ट्रिक्टेड विजिबिलिटी में, उससे क्लियर रहना होगा तो दोनों साइड सर्कल डालते हैं।
Can you ask again beta, what is your doubt actually? I'm not able to understand.
सर मैं यही बोल रहा था कि ये जो टेंजेंट है ये इस साइड में भी मारी जा सकती है, तो ये नेविगेबल वाटर में भी तो आ सकती है सर, मतलब ऊपर की तरफ ही कैसे, लैंड की तरफ ही कैसे, मतलब
Okay
PL
beta.
तो जी।
Okay, hold on now, let's go step by step. Now हमने जो ये सर्कल सेफ डिस्टेंस सर्कल पे टेंजेंट ड्रॉ करनी है, it has to be parallel to our initial PL, right?
यस सर यस।
राइट। अब दो ऑप्शन बनते हैं, एक ऑप्शन तो हमें चार्ट पे दिख रहा है, ऐसा ऑप्शन बनता है। दूसरा ऑप्शन है टेंजेंट पासिंग फ्रॉम दिस साइड वेयर द कर्सर इज राइट नाउ, दिस वे, करेक्ट?
यस सर।
So your question is why are we not drawing this particular tangent on this side of the safe distance circle, right?
यस सर।
ओके बेटा, अगर मैं यहाँ पे टेंजेंट ड्रॉ करता हूँ and I take this tangent as my course made good, तो हम तो लैंड पे चले जाएंगे ना बेटा। We want to pass a certain safe distance off from the worm's head. हमें इस डायरेक्शन में जाना है जहाँ पे ये पॉइंट C है, this is where we want to go. So we cannot go over land and pass ना।
सर वो बोल रहा है
तो
किसी
सर
केस में जैसे राइट ऑन है तो दोनों साइड वाटर हो
Yes,
सकता है,
yes.
तो दोनों साइड में पॉसिबिलिटी
Yes.
जा सकते हैं, तो उस केस में
करेक्ट
कैसे?
करेक्ट।
ओके बेटा, ये जो सवाल है, I got you. Now you are
Yes.
saying that let us say this worm's head is an island and there is navigable water all around.
यस सर यस।
ओके अब बेटा वो सवाल बनाने वाला जो है हमेशा ऐसा क्वेश्चन बनाएगा कि आपको इसमें दो ऑप्शन नहीं मिलेंगे, एक ही ऑप्शन मिलेगा। दैट डिपेंड्स अपॉन द क्वेश्चन मेकर।
ओके सर, इसमें कंफ्यूजन हो गई थी सर मेरे को इसलिए।
हाँ नो प्रॉब्लम। जो क्वेश्चन मेकर है दैट विल ही विल मेक द क्वेश्चन इन सच ए वे दैट देयर विल बी ओनली वन पॉसिबिलिटी टू पास द पर्टिकुलर पॉइंट।
ठीक है सर, ओके।
ओके, सो और बेटा एनी मोर डाउट?
सर आपने एक पॉइंट बोला था कि इट कैन बी आल्सो दे विल गिव दिस इट्स डेस्टिनेशन एज सम पायलट पॉइंट और सम अदर मार्क।
Right, beta, right. Instead of telling
सर
us that you have to pass this many miles off from the worm's head point, they may give us a certain point. Let us say they may tell us कि भाई you have to reach at the Helvik light vessel here. Okay, that also can be done. The question can be framed in that way. अब तुम डाउट पूछो बेटा।
तो सर हम जो ट्रांसफर करेंगे पीएल डायरेक्टली उसी पे डाल देंगे सर,
बिल्कुल बेटा, the line which
परपेंडिकुलर
we
टू
are
दैट
going to,
आवर टीएमजी।
yes, the second course made good which we are going to draw will pass from that particular point where we need to reach.
सर जो आपने सर बोला कि बीसी इज नॉट लाइक डिस्टेंस मेड गुड, हम यहाँ से ले नहीं सकते सर।
That's right.
क्योंकि सर क्योंकि ये कि सी हमारा एक एज ए फिक्स आ रहा है, इसलिए कि उसे वो हमें डिफाइन कर दिया है सिर्फ का पोजीशन वहाँ पे।
नहीं, ए एंड बी पोजीशन फिक्स नहीं है, वो डायरेक्शन वेक्टर है हम लोग।
शुरू में उन्होंने हमें एक पीएल दी है ना, फिक्स तो नहीं दी है। ए तो हमने कोई भी पॉइंट पिकअप किया था। somebody wanted, he could have picked up A at this place also, right? So उस केस में B
ओके
जो है वो यहाँ आ जाएगा and the distance BC is going to change. So that's why distance BC cannot be our distance to make good.
बट ए बी विल बी ऑलवेज सेम, सो ए बी वी कैन टेक डीएमजी।
That's right, beta. AB will always remain same, irrespective of whichever point you take on the first PL. AB is always going to remain same because the distance between two parallel lines is not going to change.
थैंक यू सर।
Okay.
दोनों
हाँ।
ट्रायंगल वन और वेक्टर ट्रायंगल है क्या?
बेटा आप चाहो तो इनको बड़ी या छोटी ड्यूरेशन का भी बना सकते हो, बट नॉर्मली वी मेक 1 आवर ट्रायंगल। दे आर इजियर टू मेक। जितनी हमारी स्पीड होती है उतना ही वेक्टर का मैग्नीट्यूड आ जाता है।
ओके सर।
So it can be
Sir,
also possible this E point maybe beyond B also. उससे कुछ नहीं तो चीज नहीं।
Yeah, you can do that, beta. You can do that if you want.
Because the distance
But
of the lighthouse will be
नहीं,
lesser.
but E point
So-
को E point जो है वो आपके उसमें नहीं है ना। You don't know where E point will come. आप पहले तो अपना करंट वेक्टर ड्रॉ
वो तो
करोगे।
सर हाँ सर, वो तो क्रॉस करने के बाद अगर वन आवर का ट्रायंगल बना रहे हैं, मे बी द आर्क विल क्रॉस द बी पॉइंट।
That's possible. That is possible. E point can be on other side of.
Everything will be same बोली ना सर।
What's your doubt, beta? Ask again.
मैंने कहा सर उसकी वजह से कोई चेंजेस तो नहीं होना चाहिए ना सर।
No changes at all, beta. Let us say आपका E point जो है आगे आ जाता है, forward of B, on the other side of B. It simply tells you कि जो AB distance है that will be covered in a time period less than 1 hour, maybe in 45 minutes or so.
ठीक।
So that is the only thing it tells you. Otherwise, the procedure remains the same.
ओके
sir, if the first course made good is given, then we just need to make the second triangle, sir, जो BFG वाला है.
Ask again, beta.
The first course made good we are taking as a perpendicular to this first LOP. So if the first course made good is given in the question, then we just need this BFG, na sir?
Right, beta, right. कुछ एक questions में they may give you the first course which you are steering or making good. So in that case पहले वाली triangle में तो फिर कुछ हमें करना नहीं है. So you have to make the second triangle only.
हाँ, so sir, in that case we can find the time, no sir, to reach this point C.
No, वो तो फिर भी नहीं find out कर पाओगे क्योंकि initial position नहीं पता है ना बेटा.
ये फिक्स नहीं है तो कुछ भी नहीं मिलेगा।
Okay, see after taking a position line, the visibility became restricted, so a fix was not possible.
हाँ, okay sir, understood.
Okay, व्हाट वी विल डू इज़, मैं एक प्रैक्टिकल क्वेश्चन जो हमारे पास पेपर्स में आया हुआ है ना ऑन दिस टॉपिक, वी विल डू ए प्रैक्टिकल क्वेश्चन ऑन दिस, सो देन इट विल बिकम क्लियर टू यू. एक्चुअली हमारे पास अभी, लेट मी